Greetings, math fans. Alright, so today's topic is going to be half-angle identities. Half-angle identities. Now, we've already talked about double angle, we've talked about sum and difference, so this is just one more. And I got a bunch of formulas that you have to know. And actually, what I'm going to tell you right now is that you're not going to have to memorize these formulas. You're just going to have to know how to use them. Okay, so I'm going to give you guys these formulas, and you just have to know when to use them and how to use them. Okay, so here they are. It's cosine of A over 2, again, half angle, and that's plus or minus the square root of 1 plus cosine of A over 2. And then sine of A over 2 is plus or minus the square root of 1 minus cosine of A over 2. And tangent is, let me write this on this side here, tangent of A over 2. There are actually three of them for tangent. You kind of have your choice of what to do. And the first one is really similar to cosine or sine because it's tangent, sine over cosine. So tangent of A over 2 is the sine of A over 2 divided by the cosine of A over 2. So the 2's would cancel out, and you get plus or minus the square root of 1 minus the cosine of A over 1 plus the cosine of A. Right? Just look at, again, look at your sine over cosine. Okay? And there's a little simpler version. It's sine of A over 1 plus cosine of A, and also 1 minus cosine of A over sine of A. So either one of those three are good. And the nice thing about tangent, especially those next two, is that there's no plus or minus. So you don't have to worry about the plus or minus. So actually, before we even start out here, because I want to really show you where, I'm going to talk about where this guy comes from, the sine of A over 2. But I want to talk about the plus or minus. The plus or minus is based on the quadrant of the original angle and it's using, when I say the original angle, so whatever the angle is, if you're going to use half angle, if it's 300 degrees and you're going to use half angle, you're using 300. You're not saying 300 divided by 2 and get 150. You're saying what quadrant is 300 degrees in, and then is sine or cosine or tangent positive or negative. Okay, so we're going to be using our nice little friendly chart here. All students take calculus to figure out the sine. Okay, so that is really important because that occurs in all the formulas right here. Okay, plus or minus. So you have to know again where that original angle is located, and that's going to be the sine based on sine, cosine, or tangent. Okay, so let's just talk a little bit about where the sine over A comes from. Okay, because I like to kind of show you a little bit where things come from as opposed to just like handing it to you. So let's look at sine of A over 2. It's actually pretty simple. What we're going to do is we're going to start with cosine of 2x is equal to 1 minus 2 sine squared of x. Right? You guys all know that. That's our nice double angle for cosine. Well, what I'm going to do is I'm going to solve for sine of x here. And if I do that, I'm going to move, if I add 2 sine squared of x and subtract 1, I get 2 sine squared of x is equal to 1 minus cosine of 2x. Okay, and then I'm going to divide both sides by 2. So I get sine squared of x equals 1 minus cosine of 2x over 2. I'm going to take the square root, and of course when I take the square root, I get plus or minus. So sine of x equals plus or minus the square root of 1 minus cosine of 2x over 2. And now what I'm going to do is, just because we are talking about half angle, I'm going to say, well, x equals A over 2. X is the half angle. So I would say sine of A over 2 is plus or minus the square root of, Wherever I see an x, I'm going to plug it in. So 1 minus cosine of 2 times a over 2 over 2. And finally, sine of a over 2 equals plus or minus square root of 1 minus, and that's cosine of 2 times a over 2 is just cosine of a, which is nice because it allows us to use all the single angles. All the single angles, okay, over 2. And that's where sine of a over 2 comes from. And we can really derive the other ones based on that as well. Obviously, we have that cosine of 2x. What can we do with that? If we want to derive cosine of a over 2, you just say cosine of 2x is 2 cosine squared of x minus 1, right? And then you can kind of derive it from that. Okay? All right, cool. So let's do a nice little friendly problem here. If I do cosine of 15 degrees. Now, I want to show you guys two ways to do this, right? The first way is you already know how to do that. You can use sum and difference. I can say cosine of 30 minus cosine of 15. But I'm going to show you with the half angle, and then we'll just kind of discuss it a little bit here, okay? So cosine of 15 is, I'm going to write this as cosine of 30 over 2, because that's what I'm trying to put it into. This is my value of, this is my original value, and so it's basically a over 2. You basically double that value, okay? So a is 30, because 30 over 2 is 15. If that was cosine of 20, it'd be cosine of 40 over 2, right? So you're doubling the 20 to get 40, and then you're just saying that's how you put it in the equation, 40 over 2. So cosine of 100 degrees would be cosine of 200 over 2. Okay? So we have cosine of 30 over 2, and that equals plus or minus the square root of 1 plus cosine of a, which is 30 degrees, over 2. Now let's determine that plus or minus right off the bat here. 15 degrees, that's actually pretty easy, because what's 15 degrees? Well, that's of course in the first quadrant, and they're all positive in the first quadrant, so it's really positive, right? That's pretty easy. And then it's plus cosine of 30 over 2. And let's keep going here. So it's going to be the square root of 1 plus cosine of 30 is root 3 over 2. Okay? And now we need to simplify it. This is the toughest part of this whole thing, is to simplify it. But I need to get rid of that fraction. So I'm going to multiply the top and bottom by 2 over 2. And it's inside the radical, guys. Don't put it on the outside of the radical. Keep it on the inside, because then it's almost like you don't have to worry about doing anything fancy here. So this gives you the square root of, if I distribute that 2 on the top, I get 2. Don't forget to distribute that. 2 plus root 3 over 4. Okay? And then I can actually, the top part is 2 plus root 3, and the bottom part is root 4. So you really want to rationalize that denominator and get rid of the radical. So that's why I split it up like that, and I get root 2 plus root 3 over 2. And that be your answer. Okay? So would I do it this way, or would I do sum and difference? Well, let's look at sum and difference real quickly. So if I used cosine, this is again cosine of 15 degrees is 45 minus 30, right? That's going to be cosine of 45 cosine of 30, opposite sign, plus sine of 45 sine of 30. Well, that gives us root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. So if I simplify that, I get root 6 plus root 2 over 4. Right? And you're like, what? These are completely different. Okay? Yeah, they're completely different, but if you put them in your calculator, I'm not going to show you here, but if you put them in your calculator, you get, for both of them, 0.9659. So they are the same, just written differently. Now, how would you do it? Would you use sum and difference, or would you use half angle? I don't care. I personally would use sum and difference. I just think sum and difference is a lot easier. It's a lot cleaner. I don't have to worry about rationalizing a denominator. It's just nice and clean. All right. So I would probably use the sum and difference. Now you're probably saying, well, Mr. Griffiths, why are you doing that when why are we doing that? Why are we even learning half angle? And I'm like, well, there are some problems where you have to use it. So let's talk about those problems. Okay, so basically when to use, so when to use half angle. The only time you're going to use half angle is anything with a 45 degree over 2. So basically you have a 22.5. So anything with a reference angle of 45. So in other words, it would be 45 divided by 2, or 135 over 2, which would give you 67.5, or 225. That's a 45 degree reference angle over 2, 112.5, or 315 over 2, which is going to give you 157.5 degrees. Okay, so any one of those angles is going to require half angle, because 22.5, there's no sum and difference. 67.5, there's no sum and difference to do those kind of problems. Okay. All right, so what about in terms of radians? Well, just like 45 degrees is pi over 4, well, it's pi over 4 over 2. So pi over 8. So basically anything with a pi over 8, that's when you're going to use you have to use half angle, because again, there's no values that can add up or subtract to give you pi over 8. It works for pi over 12, but it doesn't work for pi over 8. Okay, because again, it's the same thing. Pi over 8 is 22.5 degrees. Nothing adds and subtracts to give you 22.5. So basically, if you see anything with a pi over 8, and I'm not even going to list them here, because if you see anything with a pi over 8, and of course if it can't be reduced, you're going to use half angle. Okay, so let's do a couple examples here. Okay, let's do the cosine of 112.5 degrees. So you would say, if I double that, so it's cosine of, if I double that, it would be 225 over 2. Okay, so the equation, let's just actually write down the equation that we're going to use here. I think it's good to write it down right away. It's going to be cosine of a over 2 equals plus or minus the square root of 1 plus cosine of a over 2. So now the plus or minus comes in handy. Remember that plus or minus is based off of the original angle. So when I look at this, 112.5 is somewhere in this quadrant, and cosine's negative here. So there we go. It's negative. Square root of 1 plus cosine. And remember, that top number is your a. Okay, it's a single angle. All single angles. Okay, so 1 plus cosine of 225 over 2. Now, the rest of it's, well, a little bit of trig and really a lot of algebra simplified. So it's negative square root of 1 cosine of 225. The beauty of these problems is they're all going to be, if they're all based off of 45, what's the cosine or the sine of 45? It's root 2 over 2. You just got to figure out the sine. So that's actually kind of a handy little thing to know. So cosine of 225 is, look, it's right in this quadrant here, right? So it's going to be negative. So negative root 2 over 2 over 2. Okay? And then, again, you just have to rationalize things, and you don't want to get rid of that complex fraction, so you multiply by 2 over 2. So I get negative square root of 2 minus root 2 over 4. And then, again, I can split it up over square root of 4, and then my final answer is negative root 2 minus root 2 over 2. And I think, I don't know if I mentioned this already, but it's okay to have a square root under a square root like that top there. To try and simplify that is really actually quite brutal, and kids tend to cry when they do that, and you don't want to cry. Okay? So the key the key issues here, math fans, is this. I'm going to highlight this. This is a key issue right here, is this plus or minus, and also getting this sign right. Kids somehow like mess that up, but that's really important. So you got to make sure, like in this case here, it's negative, well here actually it's negative root 2 over 2. You've got to get that sign right. That sign is so huge. Okay, so two signs, that one and that one. All right, let's try a sign problem with radians. Okay, so if I do sine, we'll do black, sine of 11 pi over 8. Okay, I know I have to use half angle because it's over 8. I can't reduce it, so it's got to be a half angle. So that's the same thing as saying sine of 11 pi over 4 over 2. Okay, so let's get, well, first of all, let's write down again our nice little equation on the side. I think it's important. Sine of a over 2 is plus or minus the square root of 1 minus cosine of a over 2. Okay, so we got to determine the SIGN of this. So it's again the original problem. Well, kids always get confused of where 11 pi over 8 is. Think about it. Isn't this 8 pi over 8 right here, which is pi, and this is 3 halves. So 3 halves is 12 pi over 8, right? 3 over 2 is 12 over 8. That means 11 pi over 8 is somewhere over here, which makes sine negative. So it's negative square root of 1 minus cosine of 11 pi over 4 over 2. Now that 11 pi over 4 is kind of a crazy one as well, because we really only know up to 7 pi over 4. So what happens, just like back in the day, what happens if you have something too big? What if you have, like, 11 pi over 3 from back in the day? What would you do? Well, wouldn't you subtract 6 pi over 3 or 2 pi, right, to do coterminal? So that's what exactly what we're going to do with that 11 pi over 4. Just inside of here, we're going to subtract 2 pi one time. So it's going to subtract 8 pi over 4, which is 3 pi over 4. So now it really is the square root of 1 minus cosine of 3 pi over 4 over 2. Just makes it a lot easier to work with. I mean, 11 pi over 4, I don't know what that is. Just shrink it down to reduce it. Okay. So we have negative square root of 1. Now cosine of 3 pi over 4, again, now we're over here. And what's cosine here? Cosine's negative. So it's 1 minus a negative root 2 over 2 over 2. So that makes that positive. So we get negative square root of 1 plus root 2 over 2 over 2. And then we simplify, get rid of the fraction. So multiply the top and the bottom by 2 over 2, again inside the radical. And that gives us negative square root of 2 plus root 2 over 4. And again, you can split that up, but the square root of 4 is 2. So do you guys agree it's just negative square root of 2 plus root 2 over 2? That's your final answer. Okay. Now, while you're doing your homework, you can always check it. You type in your calculator, make sure your calculator's in radian mode, and you type in sine of 11 pi over 8 and get a decimal. And then you type in this. Just you got to have kind of a lot of parentheses in this one, and just be careful. You got two levels of radicals here. Okay. And then just make sure they're the same. Okay. All right. I'm going to do one last one here, and that is going to be a tangent problem. All right, so it's going to be tangent of 157.5 degrees. Again, you can't do this with a sum and difference, and so think about it. If I double that, it is 315 over 2. Okay, and so then we're going to say, oh, well, tangent of 315 over 2. Well, we have our choice of formulas to use here. I am not going to choose the one with the plus or minus. And the reason I can choose the one with the plus or minus is because it is, you just got to deal with it then. In fact, I'm going to deal with the third one that we learned. I'm going to say tangent, I'm going to write this over here, tangent of A over 2 is 1 minus cosine of A over sine of A. And the reason I'm going to choose that one even over the other one is because if I get a radical, it's just a lot easier to simplify it if it's just one radical on the bottom as opposed to one minus some radical, okay, on the bottom. So I'm going to use just that guy right there. Okay, so let's move on and get around to about a plus or minus. So 315 over 2, A is 315. So that's equal to 1 minus cosine of 315 over sine of 315. Okay, and so we simplify that. It's going to be 1 minus, well, 315, of course, you know, is right there, and cosine's positive. So it's 1 minus a positive root 2 over 2 divided by sine of 315 is negative. Okay, so it's negative root 2 over 2. No radical over the whole thing. This is just what it is. Now I'm going to multiply this by 2 over 2, get rid of those fractions. So I get 2 minus root 2 over negative root 2. Okay, and then really my last step is to rationalize. So I'm going to multiply, I'm going to get rid of that negative out of there too, just because I don't want a negative in the denominator. So I'm going to multiply by negative root 2 over negative root 2. Right, so I'm multiplying it by 1. So on the bottom, I just get 2. On the top, I get negative 2 root 2, and then plus 2. And I can't simplify that. If I even split it up, look at it this way, right? I can split the denominator up, and I wind up getting negative root 2 plus 1. And that's my answer for tangent of 157.5. Okay? Just because we have time, because it's a video, I'm going to do one more. Okay? Actually, I'm going to do kind of a complicated one. A little more complicated. So, it's cosine of 27 pi over 8. So before you even do the problem, you should look at it and go, whoa, that's bigger than 16 pi over 8, which remember 16 pi over 8 is 2 pi. So I can actually do coterminal and subtract 16 pi over 8, and that gives me cosine of 11 pi over 8. Okay, and then I can say, well, that's cosine of 11 pi over 4 over 2. Alright, so then I can say it's plus or minus the square root of, right, and then we're going to use a nice little friendly cosine formula. So it's 1 plus cosine of A, which is 11 pi over 4 over 2. Now, I know you're going to say, well, Mr. Griffiths, you have to look at the sign of this one, but guys, this is the same thing because it's just coterminal. So 11 pi over 8, do you guys agree we're down here? Okay, and actually then this is similar to the sine of 11 pi over 8 that we just did, but it's cosine, so let's just do it. It's not going to take too long. So we have, what is cosine down here? Cosine is negative. You guys agree with that? So we're negative, and then it's the square root of 1, and cosine 11 pi over 4, just like we did before, I'm going to say, well, I got to do coterminal, 11 pi over 4 minus 8 pi over 4. So it's really 3 pi over 4. So 1 plus cosine of 3 pi over 4 over 2. And again, that is 1. Cosine of 3 pi over 4 is in this quadrant. So it's negative. So it's 1 minus root 2 over 2 divided by 2. Multiply by 2 over 2. To simplify that, we get negative square root of 2 minus root 2 over 4, and again we can pull that 4 out and we get negative root 2 minus root 2 over 2, and that's the answer. Okay, so anyway, that's it. That's just give you a bunch of different examples, but once again, you're only using half angle if it's a pi over 8 or a 22 if you see like, a 22.5 degree angle, something with a 0.5 degree angle, it's like super obvious that you have to use it. There shouldn't be any question. And if you have anything with a 15 degree angle, it's your call what you want to use, but I don't think I'd use half angle. I think I'd use sum and difference. Okay? So that's it, math fans. I hope you guys learned a little bit about half angle identities. All right? Have an outstanding day. Adios. Goodbye.